In this video, I'm going to be talking about functions and graphs. And it turns out functions are a really important concept these days in mathematics. And there's literally whole classes on functions. So it's important that you have a good understanding of functions, and it's a huge part of what we do in college algebra. So let's go ahead and get started. It says, first of all, definition, a relation is a set of ordered pairs. And so any set of ordered pairs, which we can write in a number of different ways, would represent a relation. Now, a function is a special kind of relation. A function is a correspondence between two sets of numbers called the domain and range, such that each number in the domain corresponds to exactly one number in the range. So the basic idea here is relatively simple, but there's a lot of words here we have to deal with. So one of the words I would say correspondence. For some of you, maybe relationship would be a better word. So it's a relationship between two sets of numbers, which we call the domain and range, such that each number in the domain corresponds to exactly one number in the range. Now, another way to say this in short is with functions, each input has exactly one output. That's what we're trying to say here. All right, so let's go ahead and we'll look at a couple examples here, and I think that'll clarify things for you. So first of all, let's choose, this will be our domain, this set here, and this will be our range. In the domain, we're going to have the numbers 1, 2, and 3. And we'll say 1 corresponds to 3, 2 corresponds to 6, and 3 corresponds to 9. Now I'm going to call this the the 1, 2, and the 3 are the inputs. And 3, 6, and 9 represent what we call the outputs. And we're going to call this function the f function. And I want to introduce you or remind you of function notation. We would say f of 1 is equal to 3. That's how we say this. Notice this part here is not read f times 1, or we don't think of it as multiplication. So that's where you got to be careful. F is our most commonly used variable to represent functions. And when you see that in a situation like this, think function, not multiplication. So it's also true that f of 2 is 6, we can see that here, and f of 3 is 9. So again, you can see we have inputs and we have outputs. So it's a very important part of a function. Inputs are in the domain, outputs are in the range. So let's look at something that's not a function. So here's my domain and my range, and let's say in the domain we have 1 and 2, and 1 corresponds to 4 and 2 corresponds to 7, but 2 also corresponds to 10. So in this case, this is not a function. Now if I were to call this the g function, notice what we have here. G of let's see, what did I do there? I used the wrong letter, so this should be a G. G of 2 equals 7, but also notice that G of 2 is equal to 10. And so remember, with function, each input has exactly one output. Here we have an input 2 that has two different outputs. And so this is definitely not a function. Now I want to make a comment here. Note that if f of 1 is equal to 3, then the point 1, 3 is a point on the graph of f. So in other words, f of 1 equals 3 has the same basic meaning as the ordered pair 1, 3. Now when we see 1, 3, we think of an x and a y value. That's essentially what we have here, an x and a y value, where x values are inputs and y values are outputs. Now we can certainly use other letters, but X and Y are the ones we most commonly use. Alright, so let's see if you understand. Go ahead and look at 1 through 3 here and determine whether each correspondence or relation represents a function. So I'll let you try that, and then I would encourage you to watch the video. Alright, so, I forgot to mention with points again, we have input and output. Alright, so let's go ahead and do these problems. The first one is a function because each of our inputs does have exactly one output. 1 corresponds to 1, 2 corresponds to 4, exactly one output, and that's true for the other two cases as well. So be careful on number 2, that also is a function. Now 2 and 5 both correspond to 1, the same output, but that's okay. 2 corresponds to exactly one output, 1, and 5 corresponds to exactly one output, 1. It's okay that they both correspond to the same output. Now finally on number 3 you should have said no. Notice the 2 is the problem, so this is not a function. Notice if I were to call this the h function, h of 2 is equal to 15 and h of 2 is 19. 2 is an input that corresponds to two different outputs. And again, we know that that can't happen with a function. Alright, so I want to make one more comment here. Notice I used f, g, and h to label my functions. This is quite common. This is what we normally do when we're dealing with functions. So normally if you see f, g, and h, you're in the function realm or world, and you want to be thinking functions. Alright, let's go ahead and move on to the next slide. So here it says determine whether each relation is a function. This time we're writing our sets or our functions as sets of ordered pairs. And so I'd like you to go ahead and look at these and see what you think, whether we have functions or not here. Remember, our x values are inputs and our y values are outputs. Alright, so let's see how you did. On 4, each of our inputs does correspond to just one output, and so we do have a function. Now, on number 5, we have a problem. Notice that we have these 2 points here that have the same input but different outputs. In fact, I'm just going to make a comment here. X cannot repeat. Because when you're looking at a set of ordered pairs, if x repeats, then you're not going to have a function. So notice 2 repeats. 2 corresponds to two different outputs, 4 and 5, and so this is definitely not a function. And number 6, again, notice our outputs have repeated, but x hasn't, and so each of our inputs does correspond to exactly one output, and so that is a function. Alright, let's look at number 7 here. It says find each of the following, refer to the relations in problems 4 through 6. So on number 7, notice we're finding f of 1. So the question you should ask yourself, is 1 an input or an output? Well, 1 is the input. Oh goodness, I'm getting ahead of myself. Oh, that's right. Let me go back here. So 1 is an input or an x value. And so I want to go to the f function and look for an input of 1, and notice that happens here, and the corresponding output is 2. Oops, I did it again. Let's see. So we get 2. And next we need to find f of 4. So again, notice we're dealing with the f function. We need an input of 4. That happens here. The corresponding output is 5. Now you may want to go ahead and try number 9 and 10. They're just a little different. So notice on So since 5 is not a function, I'm not even going to pay it any attention. We're kind of partial to functions here. So if we look at h, it says h of x equals 1. Notice the 1 here is an output, not an input. And so that would be a y value. I'm looking at the h function, and I want to see which one has an output of 1. And notice that's this point here. The corresponding x value would be 5, so here x is equal to 5. All right, similarly on number 10, we're looking for an input such that h of that input has an output of 3. So notice in this case, there's 2 points, if you look at the h function, where the output is 3. So x could actually be 2 different values, either 2 or 4. All right, so now we're ready to go to the next step here. So for a given function, the set of all x values or inputs is called the domain, and the set of all y values or outputs is called the range. Now, if you look at number 4, it's actually quite easy to find domain and range when you're dealing with a set of ordered pairs. So for the domain, our x values include 1, 3, and 4, and so we're going to write 1, 3, and 4, normally in that order, inside of braces. These are called braces. So go ahead and find the range. So the range would be the y values, which would be 2, 4, and 5. Now again, I'm going to skip number 5. It's not even a function. We're just going to ignore that one. What about 6? So for the domain, you should have gotten 2, 4, and 5. And for the range, you should have gotten 1 and 3. Again, notice I tend to write the numbers in order. But the other thing is the 3 repeated, but we don't write it twice. Now, if you wrote the 3 twice, it wouldn't really matter. It's still the same set of numbers. You've just kind of wasted your time writing an extra 3. I do want to point one other thing out here. We said 5 was not a function. It turns out there's a technique, or I should say there's a rule when we're dealing with graphs to determine whether a graph represents a function or not. So let's go ahead and graph number 5. If I graph these 3 points, they look like this. Now remember, these are the 2 points that were the problem. And in fact, if you look at those 2 points, they sit vertically. So we have what's called the vertical line test. If you draw a line, a vertical line, that goes through 2 points on the graph, then what you're looking at is not a function. And so we'll come back to that later, but for now, I just wanted to point that out. Let's go ahead and go to the next slide. So here we're going to be finding function values for functions in equation form. So we have 3 functions here, f, g, and h. So if we're finding f of 0 given the function in equation form, what I do is first write down what I call the skeleton or the shell. In this case, it's f of parentheses equals 3 times parentheses minus 5. Wherever there was a variable x, now you see parentheses. So again, I call this a shell or a skeleton. And so now I want to plug in my input of 0, and I replace each x, or each parenthesis, with 0. And so our input is 0, and if we simplify the right side, we get our output. Well, that's going to be negative 5. 0 minus negative 5, or I'm sorry, 0 minus 5 is negative 5. And so on number 2, I can do the same thing. I'll go ahead and make a shell, and this time we're plugging in negative 8. And so on the right side, we're going to get negative 24 minus 5, which is negative 29. Now you look at number 3, sometimes this input having a variable in it will confuse students. But really, it's not that difficult. We're going to do the exact same thing we just did, but instead of just plugging in a number, we're actually plugging in our input, which this time is a minus 6. And so on the right side, we're going to need to distribute here. We're going to get 3a minus 18 minus 5, which simplifies to 3a minus 23. Now I'd encourage you to go ahead and do 4 through 9 to get more practice, or you can just move on to the next slide. So if you did the problems, I'm going to go through the answers real quick here, and you can check yourself. So make a shell. Now notice we're dealing with the g function now. And so we'll plug in 4. And so we get 2 times 4 squared. Let's see, we're going to get 2 times 16 minus 12 plus 5. That's 32 minus 12 plus 5, which is 25. If you do the same thing with number 5, you end up with 19. So number 6, again, we'll start the same way. We'll make a shell. You plug in 3b. So basically, I just got to do these two parts here, or simplify these two terms here. And so 3b squared, 3b times 3b, I'm going to end up with 2 times 9b squared. And of course, here 3 times 3b is 9b. Now notice there's not a plus in between here, so we're not distributing. We're just multiplying 3 times 3b. All we can do is multiply the 3's together. And so you end up with 18b squared minus 9b plus 5. Number 7, if you make a shell and then plug in 0, notice 0 plus 5, that's just 5, and 0 minus 1 is negative 1. You're just going to end up with 5 over negative 1, which is negative 5. On number 8, you should have plugged in 1. You're going to end up with 6 over 0. But 6 over 0, that's undefined. We can't have 0 in the denominator of a fraction. And so we would write the answer as undefined. What we're really saying here is 1 is not in the domain of this function, because when I plug in 1, my output's undefined. So here, this function's not defined for an input of 1. And then on the last one here, you should have plugged in a plus 4. Now you don't really need the parentheses here. We can just drop those and add the 4 and 5. We'll get a plus 9. Same thing in the denominator, 4 minus 1, we're going to get a plus 3. Now be careful, you might be tempted to do some canceling here or something like that. But we can only do that if the numerator, the terms in the numerator were actually multiplied. Here you have addition in between. There's nothing we can do. Let's go ahead and move to our last slide for this first part of our video. And we talked about the vertical line test. Here it is. A graph is that of a function if no vertical line passes through more than one point on its graph. So if you look at number 1, we have issues. In fact, here's another place. So this is definitely not a function. Notice if this were a function f, f of 0 would equal 2, and also f of 0 would equal negative 2. Same input, different output. Can't have that with functions. So that's what makes this vertical line test work. If you go through 2 points vertically, those 2 points have the same x value with a different y value. On number 2, no matter where I draw a vertical line, I can't go through 2 points. So this is definitely a function. Now be careful on number 3. Notice right in here you have problems. And so this one is also not a function, even though in a lot of places we're okay. If there's just one place on the graph where we can go through 2 points vertically, it's not going to be a function. All right, we're going to go ahead and stop this video here, and I'll do a second part